Hi everyone, this is Eric, and today we are going to look at this daily question 2264, largest three same-digit number in string. So let's look through the questions quickly. You are given a string num representing a large integer. An integer is good if it meets the following conditions. Okay, it gives us two conditions here. The first one is it is a substring of number with length 3. The second one is it consists of only one unique digit. We're gonna return the maximum good integer as a string or an empty string if no such integer exists. So what does this mean? When you do not understand the text of the question, the example I think will help you understand this much more clearly and comprehensively. So let's look at the example here because I think in Leetcode question the example is very important. So the first one is num 6 triple seven 1 quadruple 3 and 9. We output 777. Why? Because there are two distinct good integers, right? The first one is substring of num with length 3 with one unique digit. We got a 777 first, and we got a 333, and we got this 333. But 333 is not greater than 777. It's right, it's very obvious. By the way, you can compare the string. You can compare the number in the string. The string is indexable and sliceable, but it is immutable. We cannot change the value in the string. So I'm gonna show you an example of the string. Let's check out this one. Check out this one. String equals to this one, and we're gonna print mm, print string 2, and this one is from 0, right? It's a 0 1 2, and it should be output 7, and you can see we get the 7 here. But if you want to change the value 7 to something, it will show the error. You can see this one. We're gonna make the string 2 to 4, and we print string 2. You can see the string object does not support item assignment. That means we cannot assign a value in the string. We can treat it like a list. That means we can index it, we can slice it, but we cannot do this one like this. So that makes sense, right? And the second example is the number is 000 here. We got output 000 because 00 is only good integer here. Oh, by the way, we're gonna put this one here because we got a string. This one I'm gonna show you how we can compare the string number in this one. String 1 equals to this, and string 2 equals to 776, and we print. We're gonna not print this one, and we print string 1 greater than string 2. We got a what we will got, you can say we got a true, right? Because 777 is greater than 776. We compare this one digit by one digit. We compare this first one, okay, 7 equals to 7. We compare the second one, 7 equals to 7 2. And we compare to the last one, oh, 7 is greater than 6. So string 1 is greater than string 2 here. So that will make sense and will make this question much more easier, right? So let's check out this one. Um, we're gonna use a sliding window here. I'm gonna show you two solutions to this question. The first one is a sliding window here, and we're gonna define the best equals to this one. Gonna store the final answer, and we're gonna make a loop here for I in range len num. So what we're gonna write here, the range is 0 to the number in the bracket, but the number is not included, right? So you can think about this. We're gonna need what? We're gonna need num I. We're gonna need this one equals to the next one and the next one, and the next one equals to the next one, right? So in order to prevent the out of boundary errors, we're gonna need to minus 2 here, right? So for I in range, the number minus 2 here, we're gonna check if this one number I equals to number I plus 1 and equals to number I plus 2, and we gotta use our slicing here. Remember, the string is sliceable and indexable. We're gonna to answer equals to number. Oh, okay. How we slice it? We if we want to get the I2 I3 here, the triple one in sequence, we're gonna need to write like this: I and I plus 3, right? And we got the answer here, and we're gonna check if the answer, our current answer, is greater than our best. So our best is currently null, so it should be stored here, and we're gonna store again and again and again, and finally we got our the greater good integer, right? Good. I'm gonna check the good substring. The the greatest good substring, right? If the answer is greater than the best, we're gonna make this. We're gonna put. Sorry, this b. We're gonna assign the answer value to our best answer, and we're gonna return our best. So this one is solved perfectly by the solution here, and you can see, let's submit the answer. Okay, the test case, we're gonna all the test case right, so we submit here. Okay, so the runtime here is 4 milliseconds, but you may think, oh, it's already OM, so why we still get a so low bits percentage? Think about this question. It has a very special limit here. It is a substring of number with length 3. So think about this question. What is a substring of number with length 3 and consists of only one unique digit? That means this, right? 0, 0, 0, 1, 1, 1, 2, 2, 2, 3, 3, 4, 4, 4, 5, 5, 5, 6, 6, 6, 7, 7, 8, 8, and 9, 9, 9, right? These are all the let me check this. These are all the possible answers for these exactly 10 strings, right? So we only need to check from 9 down to 0 and return the first triplet that appears. That will make the question much more easier compared to our first solution, right? So let's check out this one. Okay, let's check out this one, and we're gonna write this. So how we get this one? How we get it? We're gonna compare this one first. We're gonna find if it exists in 999. If 999 does not exist, we're gonna check 888. If we check, oh, there exists 888, we will instantly output this one, because this part of here, all of the substring is smaller than 888, right? So we're gonna check to this one. If we check all the possible substring with 3 unique digits, we cannot find this substring. Then we output the null string, right? So let's check out this one. For I in what? We want to get the triple three. We cannot do like this, right? Because this is more complicated. So we're gonna need to do this one only. 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And we're gonna assign an answer like this. Triple equals to I multiplies 3. Because after we do this one, we will get 999, because we multiply this I by 3, right? 999, 888, 777, etc. So if the trip in our string, which is our num. We're gonna return this trip instantly. And if we cannot find this one, we're gonna return the null. You can see we can return the null. So we can know this question perfectly. Let me check. Oh, sorry. Oh, so, I'm sorry. I'm gonna misinput this equal here. Gonna return this one. Okay, we can say we accept our test case, or the test case is accepted, and we pass all the test case successfully, and we submit this one. And you can see our runtime is only 0 millisecond, right? We beat all our components. So, what we're gonna learn from this question is that in approaches A, the slide a length 3 window tracks the max. We gotta get ON time complexity. And the second approach is check 999 to 00 greedily. Yes, it is a famous greedy algorithm. What does this mean? It means we always put our focus on our best and our most possible answer, like this. We check 999. If exists 999, we don't need to check all the numbers in the sequence here. We only output 99 because 999 is greater any of the substring here. So we output 999 and okay, we're done for this question. And also, it's got an OM time complexity. It's very, very, very clean. And in the last one, I want to make some tiny conclusions to it. The string in Python is a immutable sequence. You can index like an array, but you can't not assign it to like this one, si. We just do this one and we will output error, right? And the second one is, why does the 999 greater than 888 work? Okay, this one. The string in Python, it has the Python compares string lexicographically for equal lengths in digit by digit. We will output true. Oh, we're gonna test this one. We're gonna output false here. Okay, this is false, right? So, the last one, what if there are multiple occurrences? We only need the largest value, not the earliest index, so both solutions will be work, right? So that is all I want to convey and deliver in this question, and I hope you guys can learn something in this Leetcode problem. So this is the first time I record a video like this. I hope you guys can enjoy it, and forgive my poor English here. So thank you very much. We're gonna see you guys in the next video. Bye bye.